So in this video, we're going to talk about how to solve this exponential equation problem. So what should be x when uh, the equation says 2 to the power of x plus 3 is equal to 3 to the power of x plus 2. So how do we solve this? The first thing to do is to take the log of both sides. So usually that's um, the way how we solve it when it's an exponential equation, but some exponential equation won't work when using this procedure. So the reason why we take the log of both sides is to put the exponent on the left side, because that's one property of a logarithm where um, you can multiply. You can use as a multiplier the one with the exponent, and change it to the left side as a multiplier, so just like this. And then we're going to distribute the logs. So we're gonna do first the one on the left side. So let's expand the x plus 3 so that we can distribute the log 2. And same thing in the right side. So we're gonna expand the x plus 2 so we can distribute the log of 3. And then, so we're gonna remove the parentheses first. And then observe that these terms, x log 2 and x log 3, are containing the unknown variable. So we want them to be put in one side of the equal sign. So maybe we put together those with x at the left side. So to do that, we're going to subtract x log 3 on both sides so that we can remove the one at the right. So we can remove that and now put the negative x log 3 at the left side. And then we still have plus 3 log 2, which doesn't have the unknown variable x, so we want to transfer it to the other side. So we're going to subtract 3 log 2 on both sides, so that this will be 0. And what's left is this, and at the right side we'll be having the negative 3 log 2. And the next step is to take out the x. That's the reason why we put together those terms with x, because we want to factor it out. So we're going to factor it out. And what's left is only the log 2 minus log 3. So we factor it out because we want to divide both sides by log 2 minus log 3 so that that will be cancelled. And the main objective is for x to be only x alone at the left side. So we're going to divide both sides so that we can cancel that. All right, so now it's canceled. So what's left is only x. So we only have this, and let's remove the parentheses for the log 2 minus log 3. And then we have this x is equal to this, but it's hard for us to check if the x value is correct with this kind of form. So we're going to change this into its equivalent decimals. But of course, usually it will give you an irrational number, and so we'll just round it off to up to 3 decimal places. So let's compute this using our calculators. All right, so now all those 4 are changed to its equivalent decimals, up to 3 decimal places. So since we rounded off, so this equal sign will change to approximately equal to. So since it's not anymore the exact value. And then we're going to subtract the top first. So we combine that, so it will be a difference of 0.051. And the bottom, so it will be a negative sign since the left side is smaller. So it will be a negative 0.176. And then we divide these two. We divide that, and we're going to have approximately negative 0.290, which is the same as removing the 0. It's the same as negative 0.29. Now let us check if we are having the correct answer. So let's have the given, and let us put this negative 0.29 into our x. So let's have the 2 to the power of negative 0.29 plus 3. So we combine the exponents. So it will be 2.71, and the other side will be 1.71. And then we're going to um, compute that using our calculator. So approximately it will be 6.54. So that is round off to up to 2 decimal places. And then uh, we'll compute also the 3 to the power of 171. I mean 1.71. So approximately it's also around 6.54. So they differ at 3 decimal places. The reason why they differ a bit because our x value is already rounded up to around 3 or 2 decimal places. But they are exactly equal if we put the more complex fraction, which is the exact value. All right, so since they are equal, then that means the x, which is approximately equal to negative 0.29, is the correct answer.